Welcome to another session. My name is Dimitris Tosidis and I'm mentor at Udacity. Today I'm going to speak about the multi-cloud course of Udacity, and I'm going to show you the multi-cloud application, which is the project of this course. This is a project that, as the name says, you have to deploy infrastructure to multiple cloud providers. So you have to deploy Terraform code, which makes infrastructure to both AWS and Azure cloud providers. So you have a common source for this both cloud providers, and we're going to deploy the code that is inside the source, which is a GitHub repository with Terraform code. So this GitHub repository is public. So I'm going to show you this right now, and I'm going to explain the things that there are going to be. Let's go to share. As you can see here, this is a public GitHub repository, which has the project of the multi-cloud computing application. This is the README, which it says that the folder contains the scaffolding Terraform, which is going to deploy the project. So you have these two resources for the documentation of the Terraform for the Azure and documentation for the Terraform for the AWS infrastructure. Dependencies are Terraform language and also Azure Access and AWS Access. So it gives you some labs in order to work in these two cloud providers and to not have any cost. I'm going to show only the code that's going to be written. So you have here open the AWS portal, which has the AWS Cloud Shell. You have to install these dependencies, this YAM utils, this config manager, and this HashiCorp. And after that, you have to install the Terraform. And you clone the GitHub repo. For the Azure portal, you have to open the Azure Cloud Shell and to select the PowerShell, and you have to leave the resource group selected. You have to change it inside the Terraform code. I will show you in the next steps. And after that, put the name and so on, and you clone inside the Cloud Shell the GitHub repo again. Okay, so the requirements is you have to deploy 4 required services: SQL Server, S3 storage, web app, and NoSQL databases. So you have to deploy these 4 services, these 4 resources in the 4 services with these characteristics. So the SQL Server has 2 vCPUs, 100 GB storage. S3 API capability has to have the S3 storage. Cloud provider for the NoSQL database with global availability and so on. And for the web app, existing .NET application is available. So let's go to see further instructions. With the requirements in mind, the scenario says that there's a team that deploys this multi-cloud infrastructure, multi-cloud project to have a multi-cloud infrastructure. So you have to use for the S3, the AWS S3. I have shown in previous session about what is the S3. I'm not going to speak about it here. You have to, they have decided for the Azure SQL, the .NET Web App, and also they have both of them .NET service and so on, and SQL service inside the Azure. And of course, for the NoSQL, they have decided for the AWS DynamoDB. I have also spoken in the previous session about that. So you have also to write down some notices why they have decided for the AWS DynamoDB and against the other solution of the Azure, for example. You have to create a diagram, and after that, you have to make the changes inside the code. So the code is 2 Terraform snippets, code snippets inside the for the AWS, it's inside the starter AWS folder, and it has a Terraform code main.tf. You have to make the changes there for the AWS infrastructure. And for the Azure infrastructure, you start again inside the Azure this time folder, and there's a main.tf file. So you also have to edit the environment variables in order to make your the resources your own. So you have to apply some rules here. So in the S3 bucket, you have to give the name, the environment variable that plays the role of the name. Here, Udacity, your name, AWS S3 bucket, and so on. For the Dynamo AWS DynamoDB service, you have to give here this name, okay, inside the environment variable. And for the Azure SQL server, you have to give this name, okay, which is inside the environment variables, and place the role of the name for the server, for the specific service that plays the role of the server. And for the Azure.NET app, you have to give this name. Okay, these are the environment variables that you have to change. Next, you have to edit the Azure DNS of the container. So you have to find where is the container and to edit this DNS here with your name. Okay, and of course you have to give the resource group that is right. So the Azure provides a resource group that you're gonna deploy their infrastructure, and you have to change it inside the Terraform code in order to be synced. Let's say so there are some predefined infrastructure of the Azure side that it is the resource group which has all the resources inside it. So you have to deploy all your resources inside this resource group, and you have to be the same as the declaration inside the name, the same as the declaration inside the Terraform code. And after your additions will start here, you write down your Terraform code to deploy the services that are asked above. Okay, so both files have some code before that in order to deploy some things that are needed, and after that you deploy your own things, which are have to be these 4 services. Okay. After you have added the modules, you apply the changes, pull the fresh copy. Okay. So you pull the copy, and after that you apply the code inside the cloud shells in both cloud providers. So some tips here around how to access and how to remove the files and so on. And here is inside itself, you pull the code. After that, you access the code inside the AWS folder. Okay, and Terraform applies the infrastructure to the inside the AWS here. You have to access this from inside the AWS Cloud Shell. And when you go to the Azure Cloud Shell, you have to go to this file inside to the file inside the Azure folder, and Terraform applies the infrastructure, deploys the infrastructure inside the Azure cloud provider. Okay. And of course, you have to wait a bit in order to all of the things to be deployed. The changes have to be took effect. So you have to find the deployed things, let's say, the deployed resources. So inside the container instances of the Azure, you click this Udacity context, and you copy the URL given, which is provided, and the exported port is 3000. So you put it at the end, the URL like that. Okay, something like that, and you see this message. Okay, this message is for the Azure. It speaks about AWS resources, and it is for the Azure to show that this is a multi-cloud application, that the Azure infrastructure access the AWS infrastructure. The opposite, of course, inside for the AWS. So inside the AWS, you have to go to the load balancer that is deployed, because there are some code that's already there in order to deploy some infrastructure. Click on the Udacity-LP, and of course there's another URL there, like that. You take that and you copy paste it inside the browser, and this is the message for the AWS, which says that the AWS is accessing Azure SQL instance, so on. So these are the instances and the Azure that are accessed by AWS this time. Okay, so you make your own pictures and screenshots. So for at the end, please don't forget to destroy your infrastructure. So you go to the file again. Terraform destroy will destroy every resource that has been created and deployed from the declarations of this in this Terraform file, which is inside this folder. Okay. For the Azure again, you go to the Azure folder and you write down Terraform destroy. You run this Terraform destroy, and all the Azure resources that are created from the Terraform file are going to be destroyed. Okay. Standard suggestions. deploy more than 2 services, go for other services too. Additional environment variables which are demonstrated on the browser. And if you want, you can make your own application with your own templates and so on. Okay. So you have to make only a diagram and to apply this for services to both cloud providers. And this is the main purpose of the project, that you are writing some Terraform code, some very easy going resources which are going to implement, deploy some services. And you have to see that everything is deployed from two cloud infrastructure are deployed from one source, which is this Terraform code. Okay. And if you want to go further, you can follow this. Okay, this is a description, a short description of the project. Let's go inside the project. As you can see here, this is a GitHub workflows folder, which has this manual YAML. Here, you pull again and again the code changes here inside the GitHub, and you apply it inside each of the two cloud providers. And here on every pull, some things are going to take place here in order to update the code, the repository inside the cloud providers. Let's go back. So the starter has these two folders again. So it is one for the AWS folder, one for the Azure folder, which have the Terraform codes. Okay, let's go to the first folder, which is for the AWS. Here you have again the config.tf, which is for the AWS deployment. And here you say that the provider is AWS, you declare it, and you say that the region is this. Okay, you declare also the region that's gonna implement deploy the resources and the default tags. Okay, some tags. Here's the main.tf, which has the Terraform code. Okay, as you can see here, there is some code here already that is gonna deploy some infrastructures. And in this infrastructure, you are gonna deploy your two services that are described in the overview, in the overall description. Okay, so there is some code here at AWS. You don't have to know this. I'm gonna read it in order to understand a bit more the project and to understand a bit more what's going on with the AWS side. Okay, so you have here the local variables, Dusty, the region again, and so on. You have the first thing, which is the VPC for the AWS, and you have this title block. Here you have some availability zones. This is the data. So if they are available, so there are some locals inside the Terraform that you declare some local variables and you define them. In the data you define them, but they have to be they are changeable from the side of the AWS. So here you define that there is some availability zone available, but there should be also available of the AWS side in order for the resources to be deployed. Okay, so you declare that in order to say, okay, it is available, let's go to deploy it, and the availability zone has to be available in the AWS. And there are some resources here. So the resources here, the subnet, which is the second thing that after VPC that you have to deploy something. And here, this is a public. And there are two actually public subnets with cider nets and so on in the given availability zone from here, if they are available. Okay, and so on. And then the given VPC. Two other subnets here, private, with other side subnet. Okay, as you can see here, the indexes. And then the given availability zone, the given VPC. This is an internet gateway with the given VPC in order to communicate with the internet, with other internet world, and to have traffic with the internet. This is a route, which is internet access, and the given VPC again, with whatever center blocks, and again with the given internet gateway, which was above. These are two elastic IPs inside the public subnets. Again, if the VPC is true and so on, this depends on the internet gateway. If you don't have access to the internet, then why to have elastic IPs inside the network? Okay, so if you don't have any access from the outer of the network, what will you have? You don't have to traffic inside the network. And again, this is some two gateways again in the subnets, in the public subnets again, which are allocated to elastic IPs. two route tables in the given VPC, and here is the route with all the IPs. And again, with this is in the NAT gateway, and these are some route table associations with the route tables. And here are the given subnets that are associated with the route tables. This is for the private subnets. This is also security group for the load balancer for the given VPC again. Some ingress and egress rules. The ingress rules is 80 port, HTTP port. The egress is whatever protocol you want. Okay, and this is again default AWS. This is a AWS load balancer with the name default. You have this name here, and for the public subnet, because the load balancing is between the these two public subnets. Security group, the given one, and so on. And this is the target group for the load balancer, which is the port 80 again, the protocol HTTP, of course, and so on. And this is the listener of this infrastructure for the load balancer. And again, this is the given load balancer, the same port, the same protocol, 80 port, which is the default HTTP, the default port for the HTTP protocol. And default action is to have this LB target group, the type forward. And this is another security group, not for the load balancer, but for the app this time. So you have two security groups for the app in general, and inside that for the load balancers. So here you have the given VPC. And here again, this is from the ports. The ports are accessible at the 3000. Okay. And as we said before, the load balancer is deployed, and you have to put the last port 3000, which is the accessible port. You define the AWS. This is defined here. Okay, and here the egress is to whatever port you want. Moreover, this is the ECS cluster. This is another resource for the ECS, which is a container resource. And here is for the ECS service something such as the name of the cluster, the task that the ECS has, and the launch type. Okay, and this is some network configuration, again, for the security group, and for the subnet, the private subnet. Here is for the load balancer target, which is has the container port 1000, and here all these resources of the ECS, which also have load balancer network configurations, depends on the listener of the load balancer. Okay, so if you don't have a load balancer, you don't have also the ECS service and the ECS cluster. Okay, let's go. The next steps. This is the output, where you can see the DNS name, and this is what you can see as an URL output. We have seen that before. So this is here is declared, and you take this. You are going to the browser. You put it, and after that the port 6000, which is the open port, and here is the ECS class definition. Okay, this is the task of the ECS cluster. Family, the VPC. These are how CPU does it want, and how much memory, and these are some container definitions. So this container service is running an image, which this is a specific image of the project. Okay, TS code of 5, AWS app, and 1.0 with this CPU, this memory, and so on, and some environment variables. Okay, that you may, if you want, you can change it in order to change your own variables, as I have said before, Azure SQL Server, and so on, with this value and another environment variable. So this is port mappings for the container port and the host port. Okay, which is again 3000. So this is a default variable here that doesn't play any role. And as we said before, your additions will start here. So the services that you want to deploy, you have to define it with the Terraform code right down here. Okay, so this is a whole AWS infrastructure with a load balancer and an ECS cluster that they're gonna have some default messages that you have to say, but also, and after that is your services that are gonna be deployed and inside this infrastructure that is already here. Okay, so you're gonna deploy a VPC and a load balancer and a CS, and inside that there are also some two services that are gonna be used. Okay, so this is it around the AWS side. Let's go to the other one, to the Azure. So again, the starter has this Azure folder. So the Azure folder has two files. The first one, config.df, which has the configuration. The configuration says here that there are required providers. This is the source, the Azure RM and the version of it. So this is gonna run on the cloud shell in order to deploy your infrastructure. And this is the features, skip provider, true, and so on. This is the provider, the Azure. And this is required here. Okay. Let's go back. So the configuration is which provider is required and which provider is gonna deploy inside the Azure the infrastructure. Let's go what's gonna be deployed. So here you have a sorted file for the Azure. So the Azure has also some infrastructure that inside that are gonna deploy the remaining two services. Okay, as you can see here, this is the resource group. The resource group is above, as you know, of the virtual machines of all the resources of the Azure resource. So you have to have it in order to deploy something. This is essential for it. So you're gonna you're gonna initiate a resource group inside the Cloud Shell in order to open the Cloud Shell and to start it. And you also have to write the name also here for the two resources to apply the same things inside a common environment. So you have here the data, which shows that. So you have here a variable that is changeable and that is dependent on the Azure cloud. Okay, it's not your resource that you're gonna be deployed here. Okay, you have to be synced, let's say, with the Cloud Shell. And after that, this is the resource. So the resource here is a container group, Audacity, with this name, and it has this location of the location group, of the resource group. The resource group has this name. Again, it is taken from this resource group that is already here. So you are given a location already from the resource group, the location of the resource group, and the name of the resource group here. Public IP, DNS name is this. Okay. And of course, the OS type is Linux. Okay. And here is inside the resource group a container, which is again a Docker container Azure up this time 1.0. And this CPU is needed and this memory is needed in order to be deployed the infrastructure that is described at the beginning. Okay. These are some environment variables that you are gonna see inside you're gonna see it on the URL that you're gonna copy and paste on the on the browser. Don't change it because these are the essential in order to see that the project is right. And these are the ports that are open, are that public available. This is 3000 again. Here is the definition, the declaration of it. Okay, and some tags. So this resource group is gonna be created, and this container is gonna be run in order to provide the right environment for the to provide this container and to host this port, to open this port, and to host the service that provides this the message for this environment variables. And after that, as you can see here, your addition will start here. So here you have to provide your own code in order to deploy the two remaining services. Okay, so you leave it this just like that. You just take care of the resource group, of course, resource group name, and everything else you don't have to change it. This gives us the message, and you apply here the two areas that you want, and this is the whole project. Okay. So your additions will start here with these two remaining services. The other file the main file of the Azure folder as also to provide 2 more services there, and the project is ready. Okay. So this was with the 2 words the whole project. I have described the change that you have to do. I have described the whole project, what it is, because we have to know what we're deploying, and it's not just the 4 services that are deployed, but the whole infrastructure in both cloud providers. I'm stopping the sharing here. I hope that you're gonna like this project. Have fun with this project. Thank you for watching. And for next project, of course, we are gonna speak again. Have a nice day.